Okay, so for the next 30 minutes, we're going to talk about scientific computing and with a particular emphasis on using Python. So like one of the themes this week is on open science. And I like this Pillars of Open Science that was from a paper by Chris Gorgolewski and Russ Poljak, where there's kind of like three main pillars. One is sharing data. And so we'll talk different ways about how people do that. We're going to use lots of open data. The other one is sharing code, and GitHub, I think, is a nice way to share code. And we'll talk about Jupyter Notebooks later this afternoon as a way to kind of store a computational narrative. And then obviously making sure your papers, you don't pay to do the research, pay to publish it, and then pay to read the paper. So open sharing and access is obviously a nice way to share and disseminate all of our work. So, hi, I'm Luke. I'm a former MATLAB addict. So this is like before I really knew any better, this is what I used to do when I was, basically up until very recently. This was my software stack. So for all my neuroimaging stuff, I would use MATLAB stuff, and I developed a lot of like my own tools to do it. For computational modeling, it was the same. So I used MATLAB for all of that and wrote a few packages for that. For statistics, I was using R. For plotting, I would mostly do R. So from imaging, I would like write out files from MATLAB and then load it into R and then make a plot with like 100 lines of code in ggplot. Scripting, I wish I dabbled in Perl and other ones. Somehow I just always came back to Bash, and my trusty old friends Aachen said, I pray that you never had to use them, because it is a terrible way to do scripting stuff. But basically, as you can already see, all of these things, even though they're all programming, they have different types of syntax. And there's this huge cost switching for me to go back and forth between these programs. And so if I was working in R for a while, if I would go to MATLAB, it would slow me down. If I went to Bash, the same thing would kind of happen. And so this kind of creates some problems for me. So the first one I noticed was when I'm in graduate school and have all the time in the world, switching costs aren't that big of a deal. But when I'm a professor and I have 15 minutes in between classes to try to do something, if I have to like spend those 15 minutes like trying to Google the command to load my data in, then those 15 minutes are going to be wasted when I could have been doing analyses. So that's just going to get worse and worse and worse. And I found as you get older, you can't do it as well. Another thing I also found since moving here is MATLAB is really expensive. So luckily the university has a site license, but I have colleagues who are other places where they had to buy their own licenses for their group. And like one group, they were going to spend $100,000 so all of their users could have MATLAB licenses and like a couple toolboxes for their group. That's crazy. So what they did was they switched to Python and spent all that money to buy a cluster instead of spending that to MATLAB for a year. So there's different types of authentications. When I got here, the Dartmouth one, it was the year before they switched to from network authenticated to like having a site license where you just have it for the year. And I was living in a place with like really bad internet connection in rural New Hampshire. And so I actually couldn't do any of my work in MATLAB because I couldn't get on the internet. And that's obviously a problem for productivity. If you work on the plane, that's another one. I found this, I first learned about this when I was using SPSS when I was like an undergrad, but sharing like data files that are like a proprietary format is like a nightmare if you ever want to work on other people's data or share your stuff with other people. And the same kind of happens with MATLAB, although you can write most stuff out to a common format. Another one we also learned the hard way is if you want to run tests on your code and you want to have it using these cool webhooks and continuous integration, MATLAB you can't install on these cloud infrastructure. So if you want to do that, you have to build your own server that's going to wait for callbacks from the webhook to trigger it on your own thing to run your MATLAB tests. Our head's already spinning, imagining, wasting my time saying that up. Oh, that's that one. The other thing we found out here is that we wanted to make sure that, because some of the tutorials are going to be in MATLAB, we spent a very, very long time trying to get MATLAB to work in a container so you can share it with everyone. And other people were doing it, but then you get these cease and desist letters if you share it on the Docker website because it's proprietary. And then also we got some licenses from MATLAB, from MathWorks, but then every time you spool up the container, we had issues and you had to keep reading the passwords, and it was a pain. Also, I haven't experienced this myself, but I've heard from colleagues who switched to industry that all of their like decade of learning how to use MATLAB didn't really fare well when their company wouldn't buy it for them. So they had to end up learning another language anyway when they moved to different career trajectories. And the most important one, I think, for me about how to like kick my MATLAB habit was like, it's like your kids, you know, you want to have them grow up in a better world than you. And so when I was thinking about like, what do I want my lab to learn and how do I want them to start their careers and what they might want to do. So maybe they don't want to stay in academia and they want to go into industry or data science or something like that. Or what's the future for, are their skills actually going to be worthwhile and useful in the future? And that was like the kind of the nail in the coffin. And so I ended up switching my whole lab over to Python. For stimulus delivery, we do our web development, and then also all of our software development stuff. Okay, so scientific Python. There's been a couple, I think, really nice, actually there's a whole bunch of stuff on this about why Python is really working well in science. So one, this was a few years ago, that's funny, 5 years ago, by Tyler Coney. He wrote a blog post about basically exactly what I'm talking about, this homogenization of scientific computing, so how he basically streamlined his whole computing stack into basically Python. Jake Vanderplas gave a keynote at PyCon recently about the unexpected effectiveness of Python for science. These slides are on the GitHub, so you guys can click the links later if you want to come back to it. And there's many, many others, peoples of different types of examples of this. I don't know why this is funny to me, but the Python personalities, they're kind of obnoxious in some ways, but then also you're really happy that they're around. So for example, these are people who have informed me in one way or another. So Gael Veracqua has somehow like created everything that I use in some way or another. Tyler Coney actually refused to work with, we're friends, we've worked for a long time, but when we were working on projects, he refused to like work with me unless I did the whole thing in Python with him. And then Satra, and then Yark is who I got tests beaten into me by, and other things. And then Chris Korgolewski has also been a big proponent. So these guys, like, not all of them, they have varying degrees of strong personalities and outgoing spoken, if any of you guys have encountered them. But there's this thing about a couple people can really take an agenda and push it really far and create tools that can really influence a community. So Gael Veracqua is one of the developers who started scikit-learn. So you guys might have heard, we'll learn about it also, which is, it's kind of probably one of the most popular machine learning libraries, probably on any platform right now. And he's a physicist, but he developed it for neuroimaging stuff. And it just, because it was so well documented and the code was easy to use, it really took off all over. Tal made Neurosynth, and these guys made NiPipe and many others. And then you'll hear about Yark's, some of his efforts later this afternoon. So another thing, you guys have probably heard about Python by now. It's super popular. It's now become the most popular search term on Google for languages right now. This is an analysis of GitHub monthly active users, and recently it's now the second most popular behind JavaScript as a kind of language of choice that people are at least using on GitHub. Like PHP and all these other ones, maybe those users don't actually use GitHub, so this might be a little biased. Okay, so why is it so successful and kind of picked up steam so quickly? So first, it's free. That's not to be minimized. It also kind of has a high-level intuitive syntax, which I think is, like MATLAB, it's kind of like easy to pick up. And unlike R, well, that's enough. It's also a real programming language. I use R also, but I find if I want to develop something, it's so slow and not intuitive for me that I don't do it. But there is many reasons why R is also can be used to describe all this stuff. It's also free and it has all the same properties I'm talking about mostly on Python. Also including being like a real programming language. So meaning, one thing that's nice about Python, it has like something for everyone, although nothing amazing at anything. So it has like you can do functional programming, you can do object-oriented programming, you can do scripting. So it's one kind of language that has lots of different ways. It also plays well with others. So if you want to call C libraries or Fortran stuff that you might want to optimize to make it faster, or if you're using other people's, you can write Python wrappers for it. I thought this was really annoying in the beginning, and now I've come to realize that it's one of the keys to why it's been pretty successful. And that's that it has a very opinionated perspective on programming and how you should write your code, and also on the style of coding. So there's like, I can't remember what the thing is to get the Python, what is it? The Zen of Python. But there's kind of like, make things explicit, try to write, as little as possible. Anyway, they have a whole bunch of stuff like when you name your variables, you should like write what you're doing with underscores. And so I'm like, that's so annoying because it's longer. But then every time I go back now, like a week later, a year later, or 5 years later, I'm like, oh, now I know what that variable does so all those types of things I think make it easier to read, first of all. And then second, because of that, it helps make the community more integrated, so people can actually like play with stuff the same way, and you can write tools that are calling other people's tools because everybody kind of has similar style that they're using. Unlike R, I'll say, because that you start using one package and get really good at it, and then you go to another package and you expect it to work the same way, and it doesn't, and that's really annoying. So now you're learning how to use that package. So anyway, this is like, it's weird, but I think it has an unintended, or not unintended, but it has a really nice consequence of making it more easily to integrate things. Yeah, and then the other thing that's really nice is we can do stimulus delivery, so CyclePy, although it has issues, but like everything, we do all of our data analysis, you can do scripting, it's installed on most, or it's easy to install on any like Unix, Windows, Mac, web development, at least on the back end. So it's nice because that minimizes your task switching quite a bit. Okay, some other kind of hidden bonuses. This is funny that you can say this now because package management used to be a nightmare on Python, but now it's gotten much better, and they've actually revamped the entire package management thing called PyPy, which you'll use like pip install something. Also, it's really easy to make documentation. In fact, when we were developing MATLAB libraries, I would use Python, so Sphinx, to basically parse the MATLAB code to generate the documentation. And this is something that can be triggered by webhooks that Yark and Eshin were talking about. Also, you can do automated testing, PyTest, and continuous integration, which we'll hear more about this afternoon. Also, easy parallelization. At the time in MATLAB, to parallelize stuff, you either had to have, they had two different independent toolboxes that were each $5,000. So if your university bought it, you were lucky. One was like a distributed computing one, which would run on a cluster. And then the other one was like, it would run on your computer using cores, but only if you use these like stupid Power4 things, which didn't actually work for anything useful. So multiprocessing is really easy on Python. And there's this also developed by Guile and others, this package called joblib, which makes it even easier to do multiprocessing. Okay, so this is, I just want to kind of introduce you. Everybody has a version of this when they're talking about scientific computing in Python. So there's Python at the center. Built on top of that are kind of like these core things that are really helpful. So IPython's one. Cython is a way where you can introduce like typing and other stuff to speed up your Python code, and it gets closer and closer to C. NumPy is kind of like, it's a matrix library for manipulating different types of arrays, and it's kind of resembles MATLAB a little bit. And SciPy also has, it's kind of like a bunch of scientific computing functions that work with NumPy. And then Jupyter, which we'll hear about next this afternoon. So built on top of that are other things. So Pandas is one that I have really come to love. It's kind of like data frames in R, except for somehow I enjoy it quite a bit more. Matplotlib is built on top of this too, so it's like a plotting library that's similar to MATLAB syntax, but is kind of taken on its own. Stats models is a library for doing statistics, and some of it I really like, some of it I'm less a fan of, but it can do most statistic, like regression-y type things. It's built by econometricians, so it has kind of a different philosophy of what they're prioritizing. Nibabble is one for loading nifty files in and out of Python. SymPy is for doing symbolic stuff, which I don't use a ton. Built on top of that are things that you'll probably actually be using more of. So just to be clear, you'll be using NumPy, SciPy, Matplotlib a lot in Pandas. But then scikit-learn, TensorFlow, which is one of these deep learning libraries that has like a reasonably high-level syntax, and it can compile down onto GPUs or CPUs, so you don't have to worry about that yourself. NetworkX, Carolyn, are you going to talk about that at all? Okay. So it's similar to the R one she's going to give her tutorial on. What's that? Oh, okay, great. So it's one of many different libraries for doing network analyses. HyperTools was, I don't know, some plotting library made here by Jeremy. So you heard about that probably ad nauseum this week because it's pretty awesome. Seaborn is another one. It's a high-level thing that's written on top of Matplotlib, but it makes plotting. So I think to make a really cool plot, there's no way around like writing a lot of custom code. But if you're trying to interrogate your data and want to just plot stuff, especially things where you have like grouping variables as like rows, that can be a pain in plotting. And they have lots of really nice kind of intuitive ways and interface to plot stuff on that. This is kind of my go-to for quickly making plots. If you're into like probabilistic programming, there's a bunch of libraries. PyMC3 is one of them. NiPipe is a really cool package. Does anyone use NiPipe in their stuff? Yeah. So it's kind of built as like a graphical model, and it treats processing that way. And you can use it pretty much for anything, but they've developed it to work with imaging libraries. So you can have like AFNI and SPM and whatever, FSL, and you can kind of mix and match, and then you just define the graph, so what the edges are, what the nodes are, and what the edges are. And then it can it works really well in clusters and parallel computing environments. And then lastly, these are like the ones these are like the frameworks that are built on top of all of this. So Brainiac's one, I don't know how widely adopted this is, probably at Princeton mostly for you guys. So one thing that's really nice about their library is they had a collaboration with Intel, so they've sped up and optimized a lot of the code, so it's really fast and efficient. NiLearn is one I use a lot, so this is like a neuroimaging library that plays well with scikit-learn. PyMVPA was developed by Yark and Michael Hanke. MNE is one for more MEG and EG, and I think there's a few other types of libraries for this. And then Neurosynth is like a meta-analysis package, which is another Python library. And I'm sure there's like thousands of these things, but these are just ones that you guys might have heard of. Okay, so something for everyone. So if you're a MATLAB user, NumPy and Matplotlib are it's a pretty slow jump to switch over because they're kind of by the same idea. If you're an R user, there's Pandas, which again kind of was started as a way for like 2D arrays to manipulate data, but it's kind of gone a lot further. There's this thing called RPy2, which allows you to send Python commands to R and R back to Python. So one thing, for example, in our lab, we had a hard time kicking what we can't really ever replace R yet for is LMER, which is like a mixed models library. And there's a lot of them, but for some reason, I happen to like that one the best. Not for some reason, it's a really good library, that's why. And it's a lot of people have spent a lot of time developing it. There's a couple alternatives in Python. So one is called Bambi, and this was developed by Talia Coney and Jake, blanking on his last name right now. Yeah, oh yeah, Westfall. And so it has like an R syntax, but it calls PyMC3, and it does like a Bayesian version of multi-level modeling. Pymer4 is a package developed by Eshin, and it basically extrapolates all of the like annoying things about using RPy2. So you can basically, it's as if when it works and installs, when it works really well when it installs, which is a little trickier depending on your computer. It's basically like using LMER in Python, and which is really nice. Stats models has a mixed effects model, but I don't really recommend it. We've gotten unreliable results that are kind of inconsistent with lots of other packages. And it's stupidly slow and doesn't scale well with bigger data sets. And then I think one of the really cool things to switch over, although again, R also has these capabilities, is these notebooks. Has anyone been using them regularly? Notebooks? Has anyone dabbled? This is like the first time you're like, I'm gonna try this out and I'm not sure about it? A couple of you? Okay, so for me it was kind of hard to get at first because I'm like, I like the command line, I like writing scripts, and I like running my scripts in the command line, I get that. These notebooks are really cool because they kind of are a hybrid where you get to have both. So you can have this interactive part where you're like typing command and you execute it right away. But unlike a command line where you have to like remember, like my working memory only has like 4, so I can only remember like a couple commands back. But now you can actually have this like history of stuff that you've run. And so it ends up being more like a script. And even better than that is the output of it can be rendered within the notebook itself and shared. And you can use Markdown to write notes to yourself or to other people or links to things. So it ends up being a really nice way to create these like computational narratives. And so what that might be is like for me, for example, I might want to remember what I was doing last week. And so I can just load up what I was doing, and I wrote out enough documentation for me to figure out what I was doing and where I left off. For other people later, if you want to share your work or your analyses with other people, these are a great way to learn from, to do tutorials. I've taught some undergrad classes using this to basically learn Python really quickly, and it's a really fast way to learn because it's like having the textbook there, but then you can, for me who doesn't like to read that stuff and just wants to like play, then you can start interacting with the code and messing with it and seeing how it works. So it's kind of get up and running faster. So one thing that's really cool that's starting to happen, and it's a little slower on Jupyter itself, but they've been working on it, is being able to collaboratively code like as if it's a Google Doc on these notebooks. So Jupyter Hub, and they have a couple things that they keep saying is going to be rolled out, but I think it's taking a little bit longer. Collaboratory is like Google's version of this, and it is essentially like a Google Doc and a Jupyter notebook intertwined. And as your notebooks, this is like the Microsoft one, is similar. And what's cool about that is you can have a link and then have multiple people working collaboratively in real time. But then if you need to scale up your analyses on the cloud, you can basically pay for their resource. That's their business model. Pay for their resources to execute your stuff on their servers. Let's see. OK, and then the last thing I just want to say is like, for those, actually I forgot to ask this. How many of you guys are actually using Python regularly? It's funny, we actually recruited all of you just for that. I'm just kidding. And how many of you guys have dabbled a little bit, but haven't fully committed? And how many of you guys have like never tried it ever, and it kind of terrifies you to thought of like doing something else? Yeah, good. Well, for those of you guys who are just getting started, I really recommend starting with Anaconda. So it's a company, and so their business model is like helping for enterprise customers, but they offer a really nice distribution that has basically everything you pretty much need to get started with scientific computing. So it has like all the things I talked about installed, except for the neuroimaging ones. And then you can do mini conda, so you can have small versions. We only have a couple packages, and it's really fast. There's a couple other things. So Jake Vanderplas has this book called Whirlwind Tour of Python, and he has a whole book as a Jupyter notebook, so you can interact with it to get started. And there's this other one I really like called Python Data Science Handbook. And it's the same. It's just like the whole book is also a Jupyter notebook, so you can click through and do all different types of data analyses. Yarrick has made a class which he's revised a few times on basically kind of introducing people to Python, so the nuances of it. And this is just a link to his class. And then we have one that needs to be updated, but it's kind of at the more undergrad level to get people up and starting. So we give this to like RAs to get started. So that's all I got. Does anyone have any questions about this type of stuff? No? Yeah, Rob. Oh, great question. Sorry, I forgot to put something. So in the past, so Python basically, I don't know if it was a good or bad idea. Time will tell. In the short run, it seemed like a terrible idea. They basically changed when they were updating from Python 2 to 3, a different version. They broke some of the API, so things work differently. So if you'd built a bunch of packages, they no longer worked on Python 3. And so there was it was weird because all the new stuff was on Python 3, but everyone was using the old version because they were so invested in that code. But now I think almost everybody has switched. All the main packages are all compatible with Python 3 and actually almost primarily developed in Python 3. And there's a bunch of cool features of Python 3 that make it even better. So it's more efficient at memory. You can do concurrent stuff, so to kind of get around the thread locking issues. I don't know, what's another cool Python 3 stuff?
Some of the like pandas and NumPy are not going to be supported forever.
Oh yeah, that's right. So some of the main packages are they're kind of stopped. They're just doing bug fixes, but they're actually adding new features to them, to Python 2 versions. So if you're just starting now, I would just recommend, I used to recommend just starting Python 2, but now I really wholeheartedly recommend starting at Python 3. And I think the newest one's like 3.7, but I probably stick with 3.6 right now for compatibility. Another thing that's really impressive is all of even though like the community is all these like random open source developers around the world, when new things come out, people are amazingly fast at keeping their stuff up to date. So anyway, I think that's really nice. Other questions about getting started? Awesome. Cool. Well, let's go to lunch, and then let's start at 1 p.m. and more. So you have about an hour and a half.